Howdy, welcome to the Texas A&M 12th Astronaut NAB NASA Students Exit Pitch. My name is Israel Gomez, the team lead for the 12th Astronaut NAB. Today, 7 diverse presenters from our team will guide you in understanding our solution and how it will help shape the future. This year, we were challenged to provide a solution to multiple mock scenarios that the Artemis generation will encounter. To help aid lunar astronauts in these scenarios, an interactive heads-up display is being tested to assist them in their everyday activities and tasks. This is the next step towards an independent spacewalk. This leads to our solution, S.U.I.T.
S.U.I.T stands for Space Communications, Operations, and User Telepresence. We engineered this UI to provide users a versatile head-mounted display with added capabilities for full control over projections. It consists of a transparent UI that grants the user spatial awareness when performing. This allows S.U.I.T to create panels for different systems in order to organize vital information in a non-abstruse way. These panels can be manipulated by the user with features such as moving, rescaling, and rotation, making different viewpoints a possibility. S.U.I.T also has a built-in telepresence that allows for real-time communication between EVA and IVA crew members. These requirements that we have instilled in our design not only provide the user with a unique experience, but also one that we can monitor. Next, we will go into how our UI is not only able to perform the mock exercises, but create them as well.
For the DCU and UIA, we plan to use 3D spatial holograms to help users with the tasks. These can be waypoints to mission objectives, such as this green sphere shown in the image or a blue arrow pointing to a certain switch or button on the DCU or UIA. We've created a virtual reality map that can be overlaid in the real world to help show exactly what to press. There's also draggable checklists that can be shown next to the items, and they automatically populate when a task is complete. For multi-user help, we've also given IVA crew members the chance to point things out using the Photon engine for networking.
For dark environments, our team has several solutions which allows astronauts to operate in the dark. We have machine learning algorithms combined with an infrared camera to generate 3D spatial maps to augment objectives and improve the field of view for astronauts. Our user interface also contains contrast settings and a virtual light to improve the astronaut's vision.
While we wait for the HoloLens 2, we use the Oculus Quest for rapid UI, UX, and networking design iteration for an EVA to IVA telepresence system. This provides the capability for an additional point of view and gives remote assistance to an IVA crew member that can have some control and oversee inputs from the augmented reality visor. Some applications of this will be to augment in real time any additional information needed, such as pointing out objects on the visor from a subject matter expert in a controlled way. This gives the visor a dynamic approach to tackle any anomalies that may appear at any time. Utilizing the Z-Mini for light detection and ranging, or LiDAR, is a great example of extra peripheral tools to obtain additional information about the environment. This information would be then used to aid in determining waypoints for direction and object classification for further AR instruction.
Welcome to the research portion. We're going to focus on the contributions to the world of AR. We have iterated on our research processes to tackle specific research interests. We've expanded the research team, our subject pool, and the ability for our research to be meaningful and effective. As you can see here, we have 3 graphs. We've had 40 plus participants in the studies we have currently conducted. And here's a few of the results we gained from our first study, which was around the best font and size of the Microsoft HoloLens to maximize retention and understanding. When you zoom in, this first one is going to be which font size was easiest to read. Our second one is going to be which was easiest to remember. And our third one here is going to be which style was easiest for the user to remember.
Referring back to the user testing we completed in the 2019 S.U.I.T.S competition, we have reiterated on our processes and used those study patterns to collect more data and user testing for our UI to be the most effective and productive in task completion. This year, the S.U.I.T.S team had a paper published at the Institute of Electrical and Electronics Engineers Aerospace Conference in Big Sky, Montana, in March 2020. We also have submitted an abstract to several other conferences, including the American Institute of Aeronautics and Astronautics Ascend Conference. We intend to publish more work with our research that we are doing with S.U.I.T.S.